Batteries. Batteries are galvanic cells, which are maybe a combination of one or more than one galvanic cells which are connected in a series. Now we know that generally in a torchlight we have more than one small batteries. These are connected in a series plus minus plus minus plus minus. Like this, number of connected in a series that should be more than one. So these are two type batteries. Actually, what is that? Which converts chemical energy into electrical energy. That is nothing but a galvanic cell. So a spontaneous redox reaction that convert into electrical energy. Batteries are two type. One is primary battery, another one is a secondary battery. So now I am discussing about primary battery. Primary battery is an electrochemical battery which act as source of electrical energy without being previously charged up by an external source of electrical current. Now you take one small cell which is used in the remote or torchlight. That is, when you purchase from the market, that is a new cell that is not charged up, because in that what is present, electrodes and electrolyte is present. They undergo oxidation and reduction. That redox reaction spontaneously occur, which convert into electrical energy. That's why a primary cell or battery act as a source of electrical energy without being previously charged from external source. It is not charged from the external source. We are not putting a plug into the battery and charging. That's why it is not charged up. Only itself it gives a chemical reaction converted into electrical energy. For this, one example for primary battery is a dry cell. This is also known as lec Leclanche cell. This name given based on the scientist who prepared this one. So Leclanche cell. Now, what is this cell? In this first, what are the anode, cathode and electrolyte present, that I will discuss first. So first one is anode. Anode according to galvanic cell mean what is that? Negatively charged, because this is now which one? It is a galvanic cell. Galvanic cell signs are anode negative, cathode positive. Because now it gives chemical energy to electrical energy. So a zinc is act as anode. This is a container. If you observe that a dry cell, around the a graphite rod we have a zinc plate, or that is called container, that act as a anode. Next, cathode. Cathode according to galvanic cell, that is which one? Positively charged. So now what is a cathode here? A graphite or carbon graphite. This is surrounded by powder MnO2, manganese dioxide, black color powder. This is, and a carbon. This is called cathode. Now we will discuss the what are the reaction at anode and cathode. So that, what is the electrolyte? Electrolyte in this reaction is, this is placed between the space present between the anode and cathode. So that is a moist paste of ammonium chloride and zinc chloride. So this is anode and cathode and electrolytes. Primary battery once discharged cannot be recharged. So here I can write primary battery once discharged cannot be recharged. That is called battery dead, means throw out only. It is not reused. H anode. At anode, which reaction takes place? Always oxidation reaction takes place. So I will write here oxidation reaction takes place. Now, zinc convert into zinc plus 2 electron. That is called oxidation. Loss of electron is called oxidation. At cathode. Cathode means what is that? Positively charged. Which reaction occur? That is reduction reaction occur. And one more thing I forgot here. So in this cathode reaction is, now what is present at cathode? MnO2 powder and this electrolyte having which one? Ammonium ion, because ammonium chloride present. So whatever the last electron from the anode that is gained here at cathode, then this will be converted into MnOOH plus this will be converted into ammonia. Now keep in mind, sometimes they are asking the question, what is the change in oxidation state of this manganese? Here plus 4 oxidation state and here plus 3 oxidation state. So change in oxidation state, how much? 1. The difference is 1. And now the form of zinc plus 2 ion, zinc plus 2 ion and this ammonia both combine together and form a complex, that is zinc react with ammonia and form a complex, zinc complex. Here 4 times, here plus 2 charge, therefore here this is a 4 times. Like this complex will form. And this cell potential, that is E naught cell value is equal to 1.5 volt. Now this cell generally used in transistors and clocks. According to our textbook, these two uses are given. Generally, it is used in the radios also and the children toys which are having some small battery. In that also, we can use this dry cell. This is about the a dry cell or Lakeland cell. Very important for board level, for competitive exam level is you have to remember what is the anode reaction, what is the cathode reaction, and what is the cell potential. Cell potential for this reaction is 1.5 volt. Next one is mercury cell. This is also one primary cell. Now compare with this dry cell, it is suitable for low current devices like hearing aids, mean like headphones, earphones, and watches. For that, this is used. So, first of all, we will discuss what is the anode. Anode is negatively charged according to galvanic cell, because this is galvanic cell. So, what is a galvanic cell here? Anode, zinc amalgam. In zinc amalgam, this is a more active. That's why in a reaction which is participate, zinc participate, mercury not, mercury like in amalgam like little inert. Therefore, which is participate at anode, zinc participated. Next, at cathode. What is a cathode? Cathode is positively charged. Then what is the cathode here? A mixture of HgO and carbon act as a cathode. Next, electrolyte. What is the electrolyte here? Here also a paste of KOH and zinc oxide. This is act as an electrolyte. Now, what are the reaction at anode and cathode? We will discuss. But so now at anode reaction, which reaction takes place? Oxidation reaction takes place. Now, zinc amalgam at anode participates, and this OH minus come from the KOH as electrolyte. This will be converted into zinc oxide plus water plus electron. Now we have to balance it. Right side, how many oxygens are present? 1, 2. Therefore, multiply with the 2. Now left side, how many negative charge is there? 2. Therefore, right side 2 negative charge. Now left side 2 hydrogen, then right side also 2 hydrogen. Balance. This is generally solid form, and remaining liquid we know that, and aqueous form. Now here mercury is not participating in the reaction, that's why not written here in the balancer. Just keep it side, otherwise no need to write in the equation also. Then at cathode, which reaction takes place? Reduction reaction takes place. So which is present at cathode? Mercuric oxide plus whatever the loss in the anode, that will be appear. Then this will be converted into, now you check that this is gain of electron. Then this H2O and O convert into which one? OH minus plus this mercury separate. Now you observe here, left side 1, 2 oxygens are there, therefore 2 negative charge is there. 2 negative charge left side now, and mercury 1 form. So this is which one? Liquid. Remaining are cancel out. Cancel out or not, we can check now. So electron cancel, OH minus cancel, H2O cancel. What is left now? Zinc amalgam left plus HgO left, and convert into zinc oxide and plus Hg. So now in the final equation we have liquid or solid substances are present. Therefore, their concentration do not change in the net equation. Therefore, compare with the dry cell, its concentration not change, as well as cell potential also not much varies compared with the dry cell. Now, its potential, cell potential value E cell is equal to 1.35. Already I told you that this mercury cell used in the low current, devices like hearing aids, watches, etc. And its lifetime is little better because reason concentration do not change in the net equation, that we have to remember. Next one, for secondary battery. Now secondary cell is one in which electrical energy from an external source first converted into chemical energy, that is called electrolysis, that is nothing but electrolytic cell act. When the external source is removed and the cell is made to work in the reverse direction, that is called galvanic cell. Now cell battery, first we are using, then battery will be discharged. That time when it is used, that act as a galvanic cell. When totally discharged, then we'll plug in into the socket, then it is charged up to 100%. That time it is which one, electrical energy from the external source, from the socket we are putting into the socket, then charging this one, then that time electrical energy converted into which one, chemical energy, that is electrolysis. After removing the charge from the socket, then it is 100% complete. No? That time it work in the reverse direction, mean chemical energy converted into electrical energy. Then that mobile phone we can use. So when mobile phone in use, that is called galvanic cell. When it is discharged and we are charging with the external source, that is called electrolytic cell. There electrolysis takes place, and in galvanic cell oxidation reduction reaction takes place, that is spontaneously, that convert into electrical energy. So once again very clearly I am telling that when the cell is in use, that act as a galvanic cell. When totally discharged, then we have to plug in from the socket, then we will get the electrical energy converted into chemical energy, that is called electrolytic cell. Now a secondary cell, after its use, it can be recharged and can be reused again. Therefore, I can say here a good secondary cell undergo number of discharge and recharge cycle. But now you can consider for secondary battery, if undergo discharge, again we can recharge. The better battery or a good secondary battery which undergo number of discharge and recharge. Now we have the cell phone in that battery we are using, then discharge again charge, like this in a 1 year or 2 year or 3 years, number of time we are using and it is recharging. Therefore that battery is a good battery. Now one example for secondary battery is which one, lead storage battery. Example for this, lead storage battery, or this is called also acid storage battery. Now in this also we will discuss first what is the anode. Anode is a PB. Next, cathode. Cathode is a lead grid or rod. So we can call a grid of lead. is packed with lead dioxide PbO2, that is called cathode. Now, electrolytes. What is the electrolyte here? 38 percentage of H2SO4 is the electrolyte used. Now we will discuss its reaction at anode and cathode. Now keep in mind, in charging time and discharging time. So generally we are using, what is that? Galvanic cell. Galvanic cell meaning what is that? Cell in use. Cell in use meaning that is called discharge. So whatever the reaction I am writing, that is cell in use or discharging time. Now at anode. At anode, what is the charge when galvanic cell? Negative. So what is the reaction takes place? Anode in electrolytic cell or galvanic cell, oxidation only takes place. Then oxidation. Then this one Pb plus SO4 minus 2, that will be converted into PbSO4. Pb loss electron, that is 2 electron loss. Next, H cathode. At cathode, what is the charge? Positive when galvanic cell. Which reaction takes place? Reduction reaction takes place. Now we have at cathode is PbO2 plus SO4 minus 2 comes from the electrolyte, and H plus also from electrolyte plus electron. This will be converted into PbSO4 plus H2O. Now you have to balance this. Then 2 electron loss from the anode, therefore 2 negative charge, and we have to balance right side no charge, meaning totally here 2 negative, 4 negative, therefore 4 positive required. Then I think balance 1 Pb, 1 Pb, oxygens are 2 in the PbO2, therefore here 2, then balance. Now net equation. What is the net equation now? This 2 electron cancel, remaining anything not cancel. Therefore, I can write this as a net cell reaction. In this net cell reaction, Pb plus PbO2. Now all these together, I can write this is 2H2SO4, and this 2 moles are there, then 2 PbSO4 plus 2H2O. This is a net equation when it is discharging time, and its cell potential E naught cell is equal to 2.1 volt. 2.1 volt. And this is used, and keep in mind this reaction is when discharging. Carefully you have to remember this reaction when discharging time. And this lead storage battery used in which one? Automobiles and in inverters, etc. Now in competitive exam or in board level exam, they may ask write the net reaction in recharge time. Recharge, very important. Recharge time, this equation is reversed. So reverse reaction is 2 PbSO4 plus 2H2O and gives rise to Pb plus PbO2 plus 2H2SO4. This is called recharge time reaction. Now keep in mind, generally many members know that in automobile battery, when it is low or not stored the car, that time uh, battery low condition we have to consider, and we are adding which one, distilled water. Then distilled water we are adding in, what is that, that is charged up. That's why left side H2O required for recharge, and when discharge time H2O right side required. Recharge time left side, discharge time right side required. And when cell in use mean H2SO4 should be left side required. When cell is recharged meaning we are producing which one, H2SO4. So keep in mind a 12 volt small battery having how much, 6 batteries in a series, because its value how much, cell potential 2.1 volt. So like this 6 batteries in a series connected mean 1 2 3 4 5 6 mean this total voltage is how much, 12 volt. Now this lead storage battery, when voltaic cell meaning galvanic cell when discharged, then what happened, this is at anode reaction, oxidation takes place. This is cathode reaction, reduction takes place. Both these oxidation reduction reaction convert then electron transfer like this. In voltmeter will get the reading. Now at anode there is a negative charge galvanic cell, at cathode this is positive charge galvanic cell. Now when this is discharged completely, then we have to charge, that's why power supply here, then we will get a anode become cathode, cathode become anode. So this will be reverse direction made. That's why here what reaction takes place, negative charge here only, but anode become now which one, cathode. Then here reduction reaction takes place, therefore this is PbSO4 gain electron in H plus and come to Pb. Reverse happen, and at cathode this reaction takes place. Total overall reaction already I given. So now I given this one half cell reaction in anode cathode reaction, but this direction observe here. Power supply to which one, electron given to cathode. But here anode undergo oxidation, this electron given to which one, uh, cathode, like this. So electron transferring is in the reverse direction compared with the galvanic cell. This is helpful. So this battery it is present in the automobile. So that battery taken like this and shown here. I hope you understood about the which one, secondary battery, that is lead storage battery. Next one, nickel cadmium battery. This is somewhat expensive and it has a longer life. It has longer life and expensive. And in our textbook not much more detail discussed. So the net reaction given here, that is cadmium plus 2 nickel trihydroxide convert into cadmium oxide. All of this is solid, this is also solid, this is also solid, and 2 nickel hydroxide, this is solid. Its cell potential is nearly E naught 1.4 volt. So somewhat expensive and good lifetime. This is about the nickel cadmium cell. So I discussed today about one primary battery. In this primary battery we discuss about the one dry cell. Second one is mercury cell. Secondary battery. In this one lead storage battery, and second one in this nickel cadmium battery.